Hey guys, this is Diamond from the Oppenheimer Ranch Project. I want to do a video on why the Houston flooding isn't a sign of global warming, because I'm really sick of all the mainstream media coverage on this historic storm being a sign of climate change. What I have up here is a graph from 1970 to 2014 of global tropical cyclone frequency. This is a 12-month running sums. This is the total number of hurricanes on the bottom and tropical storms on the top. And as you can see, it goes up and down and up and down and up and down as time passes. There's even a downward trend here from 1998, which is peak global warming, to present. And that has to do with solar cycles, which I'll do a different video on solar cycles. But this is just about the Texas storm. So you've seen that graph. Here's another good way to look at it. This is major hurricanes striking the U.S. each decade since 1850. And it's really clear here that the peak hurricanes striking the U.S. was in the 1950s, not today. In fact, there's a downward trend from 1950 till today, according to that graph. And here we can have the North Atlantic hurricane season, accumulated cyclone energy, similar to the first graph, showing the same trend downward. Downward. And now let's just face the facts. Have there been any storms like Hurricane Harvey? Well, let's just go back to 1900 in Galveston. It was a total loss. Look at this picture. A total loss in 1900. That was a hurricane of Galveston right there. Total loss, 100%. You're not going to find that in Harvey. So if they try to tell you this is unprecedented, they're lying, because there's right there is Galveston. Here, another picture of Galveston. Total loss. It's kind of funny because we can even find a similar happenstance in Houston. Right here. 1935. Houston, Texas was completely decimated. Almost a total loss. Worse than Harvey. In fact, I want to show you this. So this is Houston in 1935. And here's a USGS map, a graph here of Buffalo Bayou peaking out during Harvey at 38 feet. In 1935, it was at 54.5 feet. That's 17 feet higher than this. That's up here. It's so based on that stat alone, they're ripping you off. So let's look at some more pictures of Houston. There's Houston underwater, 1935. Again, Houston underwater. You will not see any pictures of Harvey looking like this. Another shot of Houston. It was a Category 4 that struck Galveston in 1900. Total loss. Is this an unprecedented event? I don't think so. What's unprecedented about it is that with all this information, the hurricane in Galveston in 1900, total loss. The flooding in 1935 in Houston, total loss. That the infrastructure hasn't changed. We're still building in the same low-lying areas where these hurricanes are going to happen. So we need to wise up quickly. Because in these areas, these storms are going to continue to happen. It's just a fact. I just showed you the facts. Thanks for watching. Subscribe to our channel and share this video with like-minded individuals. Hey guys, this is Diamond from the Oppenheimer Ranch Project, and today we're going to do a video on sea levels and why catastrophic sea level rise and alarmism is complete nonsense. So what I'm showing you here in the beginning is all of the data we have on global temperature, CO2 concentration, and sea level for the last 450,000 years. We're right here at zero. The Holocene, modern time, is right here, and this is the last 500,000 years. I have some black lines on here drawn so you can learn a quick lesson about CO2 and temperature. After temperature rises, CO2 rises. It's a cause and effect, as it's not the other way around, which is why global warming makes no sense. Also, the amount of CO2 in the atmosphere is negligible compared to water vapor, which is the main greenhouse gas, and we should be more worried about that after the information that came out of the Cloud Project at CERN and Svensmark, the cloud mystery. We now know that cosmic rays cause cloud nucleation, which causes an increase in precipitation and global cooling. We'll get into that later, but what you see here is up and down, sea level rise, up and down, huge amounts. This is 100 meters. Then you see the CO2 concentration up and down, matching the same pattern as global temperature matches the same pattern as CO2 concentration, matches the same pattern as sea level rise and fall. But what I want you to notice here is there's a huge lag time between sea level rise and temperature rise, in the order of thousands of years, 2,000 to 3,000 years. The temperature peaks, and then 2,000 to 3,000 years later, the sea level rise peaks. Now, why would it take thousands of years for ice melting to rise sea levels? Because that's a common misconception. Ice rising does not cause sea level change. And right here should tell it all. Al Gore owns a $9 million mansion that's oceanfront, and he bought it during peak global warming hysteria. Well, why would he buy an oceanfront villa if he thinks the sea levels are going to rise catastrophically? Someone please tell me that. Well, in the first graph you saw the temperature going up and down, the carbon dioxide going up and down, and the sea level going up and down, all pretty much matching the same pattern. If you come look at the periodicity of these cycles, it's in the number of 100,000 years. These are 100,000 year cycles. Within the 100,000 year cycles, you can see smaller scale cycles. There's different periodicities here. Within each 100,000 year cycle, you can see 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 cycles. What are those cycles? What's driving this pattern? Well, if you weren't aware, the mechanism are the Milankovitch cycles. The Milankovitch cycles are orbital perturbations that were first revealed by Milankovitch in the 40s. He's a mathematician. And he determined the celestial mechanics of the precession of the equinoxes, the obliquity of the axis of rotation, and the eccentricity of the orbit of the Earth around the Sun. It may be hard to comprehend if this is your first time, but I'm going to try to keep it simple. Approximately every 19, 20, 24,000 years, the Earth wobbles. So about every 20,000 years, the Earth wobbles. The north axis goes in a circular motion pointing towards and away from the Sun as we rotate in the solar system. Every 20,000 years, the North Pole is facing towards or away from the Sun. So 10,000 years away and 10,000 years close, that's one cycle. 20,000 year cycle is a precessional cycle. Now, every 41,000 years, there's an obliquity change, which is the amount of tilt, and that affects the amount of precession of the equinoxes. And on top of all that, within a 100,000 year period, the Earth's eccentricity, the orbit of the Earth, the circular nature of it, is more circular or more oblate. And in a 100,000 year period, it goes from circular to oblate, just like that. Now, the eccentricity is a contributing factor to the expression of the precession of the equinoxes. This always happens, and it's either greater or less based on the obliquity and the eccentricity. All these add up to what you see here, the solar forcing. The solar forcing, you see rises and falls, but it maintains the 20,000 year precessional cycle, which spikes every 100,000 years during the eccentricity spike of the Milankovitch cycle. So these are the 100,000 year cycles. Within it are the 20,000 year cycles. This solar forcing is what we want to be focused on, because this is what drives the climate, not man. The total solar irradiance drives climate. Here we're looking at cycle 24, 23, and 22. There is an 11-year solar cycle, even smaller than the 20,000 year solar cycle. The 20,000 year Milankovitch cycle that's driving the climate. So at every level, it's almost like plasma scaling. At every level, there's something driving the mechanism. Well, this is the mechanism of rise and fall in temperature, the 11-year solar cycle. And the reason I can say this with good confidence is that there's a correlation. Here's the correlation graph. It's amazing. If you don't know this, I'm going to reveal it to you right now. Move this out of the way. But the red line here is the total solar irradiance smoothed. And the blue line here, smoothed meaning they took all these peaks and valleys and smoothed them out. That's it. And the brown up and downs, those are the 11-year solar cycles, which happen like clockwork. If you do an overlay of the total solar irradiance smoothed versus global temperature, the correlation is excellent, meaning that the total solar irradiance, or TSI, has a direct connection to global temperature. So if you didn't know that, now you know. Now what does this all relate to sea level? Good question. Let's come back to let's go over to the Holocene. So at the end of the last ice age, sea levels rose dramatically, 140 meters, and the Clovis culture was inundated with water, 300 feet. Their settlements are now all 300 feet under 300 feet of seawater, because a lot of the Clovis culture lived on the coast of the United States. And from 16,000 years ago to their decimation around 12,000 years ago, sea level came up 60 meters, 200 feet. So if your city was anywhere near the coast, goodbye. So this massive sea level rise was caused by one of those Milankovitch cycles, and that caused us to come out of the last major glacial maximum here, and that into the Holocene here, where you can see sea level rises have been very slow. Let's get closer up. If you go just Google sea level change, you're going to see this graph. It's Church in white and blue, and the University of Colorado in red. This is a typical global warming alarmist graph. It goes straight up, and it goes even further up. So, and it even shows you the rate of sea level rise going from less than 1 millimeter a year for this period to 2 millimeters a year for this period to over 3 millimeters a year for the most recent period of the global warming scare here. I'm going to show you why this graph is total nonsense. Here's the IPCC's graph of global sea level change. And you can see right here, in the last 20 years, that sea level rise has slowed down relative to this period, relative to this period. So it was actually faster from 1930 to 1960 than it has been from 1960 to today, which is the exact opposite of this global warming scare graph. So delete it whenever you see it. This is the real data, and what it shows you is sea level is flat. And then from 1930 to 1960, it rises rapidly, and then sea level's flat. And then from 1990 to 2000, it rises quickly, and then it's flat. It doesn't show you it catastrophically, exponentially rising up and drowning everyone. It doesn't. And the reason is because the sea level rise isn't caused by melting ice. Many people think it's from melting ice. But it's from density change. What's up with that? Sea level rise. Here's solar irradiance and temperature. This is a pretty good match between the sun and the temperature on the earth. I think it's direct. So when they say that you're causing global warming, no, the sun is, if it is warming or cooling, because the sun controls the temperature. Here's a perfect graph showing you that. But let's get back to the why sea level rises. Sea level rises because of a phenomenon called thermal expansion. As the ocean warms, the density decreases, and thus, even at constant mass, the volume of the ocean increases. This thermal expansion, or steric sea level rise, occurs at all ocean temperatures and is one of the major contributors to sea level changes during the 20th and 21st centuries. Not man, thermal expansion. And as I showed you in the very beginning of this video, the sea level rise comes much later than the temperature rise. And that's because the oceans take a while to heat up and expand. It's as simple as that. So sea level rise is not caused by you because you're throwing garbage out or you're not carbon neutral or whatever. It always happens, and it goes up and down and up and down. So what you're looking at is a 3D graph of the thermal expansion of the ocean. And water is a very unusual material. It's most dense at 4 degrees C, so the deep oceans are around this temperature. And as the water heats above, it expands. So if we were in a global warming Earth, the ocean temperature, or the ocean sea level rise would not go up and down and up and down and up and down and up and down and peak in 1950 and go way down and then up and down and up and down. It would go straight up from 1950. But it doesn't. It goes up and down, and then further down, and then further down here in 1970, and then up, and then even lower, and up and down, and up and down. And it peaks here in like 1990s, and then it comes down and up and down. So you could see that the sea level rise is not constant. It's not catastrophic. It's not exponential. It's slow and gradual and random, and it follows an 11-year cyclic pattern that's driven by the sun. Let's talk about rates of sea level change. So we saw here in modern times, sea level rise is almost negligible. It's very modest compared to other periods of time when it actually is catastrophic. Not now, but has been. And as you can in fact see in recent times, the amount of sea level rise, which is only millimeters, it's tiny little bits, has actually leveled off. And there's some good papers out that show you some things here. Here's a great graph. This is the actual data of sea level rise since 1990 till today. Here's the IPCC's projection, Arnold Schwarzenegger's projection, Al Gore's projection, actual data of the catastrophic sea level rise there. Nothing happening, folks. Nothing to see there. Let's talk about the rate of change, though. This is a blurry graph, but this is coming from 1, 2, 3, 4, 5 sources, including NOAA. And this is the actual sea level trend in millimeters per year. The rate of rise of sea level in millimeters per year. And you can clearly see on this graph that in 1998, the rate of rise of sea level, according to 5 independent sources, was 3.5 millimeters a year. 6 years later, 3.5 millimeters a year in 2004. In 2006, according to 5 independent sources, the rate of sea level rise had dropped a staggering 70% to 2.4 inches, 2.3 millimeters per year. The amount of sea level rise halved by 2008, according to one source here. According to NOAA, The rate of sea level rise has dropped by 50% from 2000 to 2008. It hasn't gone up. It's not catastrophic. Every headline you see says, oh, sea level rising faster than anyone ever expected. No, it isn't. All the sources on the planet agree that the rate of sea level rise is dropping. Don't believe the hype. Here's another great graph. Here's the rate of sea level rise from 1995 to 2008. And it goes from 4.3 millimeters a year all the way down to 2.3. A drop of 80%. So the rate of sea level rise has dropped 80% from 1995 to 2008. The total amount of historical sea level rise we can come up with on all charts since 1850 is 20 centimeters, which only amounts to 7.8 inches ever, anywhere, which is this amount you can hold your thumb and your pinky finger away from each other. That's how much global sea level has risen, and it has now slowed down to 2.3 millimeters a year. Again, here's a great example of solar irradiance driving temperature on the Earth. I hope you enjoyed the video. I want to leave you with something as we go here. If you see this picture to scale, you can see where sea level is here in current times and see where sea level was in 1898 here on the Statue of Liberty. It looks a little higher back in 1898, to be quite honest with you. It looks like it's dropped here in the harbor. Get the facts, share this video with people you love, and spread the truth. Subscribe to our channel. Thanks for watching.